What if the best way to save your underperforming team is to make everyone play a role they've never touched before? Most coaches fear change, but elite organizations use the mathematics of derangements to force growth. By the end of this video, you'll master the logic and code behind a total roster reset. Pause if you don't understand how permutations work under constraints. You're leaving your team's performance to chance. Without these mathematical tools, you risk falling into fixed-point traps that keep players in their comfort zones while your win rate plummets. Let's see how the pros mathematically guarantee a fresh start. Pause in combinatorics. A derangement is a permutation where no element appears in its original position. For a 5-player League of Legends team, there are exactly 44 ways to do this perfectly. But how do we calculate this for a 20-player multi-game organization? The numbers grow faster than you think. Pause, this isn't just for gamers. From military unit reorganization, after failed missions to how top-tier tech leads shuffle engineering pods to prevent cliques, total derangement is a proven industry standard for revitalizing human systems. It forces players to adapt, learn, and break entrenched, losing strategies. Pause to solve this, we look at Player 1. They have N1 possible new roles. But here is the tension. Does the person who originally held that role take Player 1's old spot in a simple swap, or do they move somewhere else? Think about it, which scenario creates more chaos? Pause, if they swap, we need to derange the remaining N2 players. If they don't swap, we are effectively deranging N1 players because one position is now forbidden for a specific player. This leads us to our beautiful recurrence relation that powers our code. Before we see the Python, can you guess the value for n equals 4? Pause, here is the implementation in Python. It's clean, but notice the complexity. While 2 to the power of n is slow for massive datasets, it's perfect for analyzing a standard 5v5 roster. We handle our base cases. You can't derange one person, and 2 people have exactly one way to swap. Pause, for a massive 20-player organization, the recursive version hits a wall. By switching to an iterative approach, we calculate the 18-digit number of possibilities in milliseconds. This is a variable reward for your CPU, shifting from exponential drag to linear efficiency. Pause, sometimes a total wipe is too radical. Maybe you want to keep your star mid laner, but shuffle everyone else. This is where partial derangements come in. We use the binomial coefficient to choose who stays, and then derange the rest. This offers a balanced way to revitalize without total chaos. Pause, we've covered the full spectrum, from the psychological need for total derangements to the recursive and iterative Python implementations. You now have the tools to calculate roster possibilities for any size organization and understand the mathematical why behind the chaos. Pause, remember, for a 5-player team, you have 44 unique ways to completely reinvent your dynamics. Whether you choose a full reset or a partial shift, you're no longer guessing. You're using the same logic that high-stakes military and tech organizations rely on every day. Pause, if you keep using the same roster logic, you'll keep getting the same results. Don't miss out on mastering the algorithms that define modern team optimization. Join our Code Assist Pro Bootcamp today and turn these mathematical concepts into career-defining skills.